This video is for lesson 21-1 about 45 degree, 45 degree, 90 degree triangles. Learning goals are to describe the relationships among the side lengths for these kind of triangles and then use those relationships to solve problems. For our notes, let's skip all the way ahead till you find question 4. Before we work on number 4, let's first work with the 45, 45, 90 degree triangle a little bit. Over here on the left side of the screen, I'm going to draw one of these triangles. This is a very common type of right triangle because it's created by taking a square and then drawing a diagonal in that square. That creates two triangles. Both of them are called 45, 45, 90 degree triangles. Let's just look at this bottom left triangle. It has a 90 degree angle here, and because this angle was bisected, it's 45 degrees. Similarly, this angle is 45 degrees. Because the original shape was a square, this side and this side are equal to each other. Now what this lesson is about is 45, 45, 90 degree triangles and the side lengths of those triangles. Is there any relationship that we can discover and then use to solve problems? So let's make an example problem. Let's say that the side of the square is 5 units long, and then so is this side. How long would the hypotenuse be? Let's call it C for now, and use the Pythagorean theorem. So 5 squared plus 5 squared equals C squared. This is 25 plus 25, which is 50. To solve for C, we can take the square root of 50. The next step, I'm going to use something from algebra class. 50 itself is not a perfect square, but 50 can be factored as 25 times 2. And then we can take the square root of 25. It makes 5. We can't take the square root of the 2 without getting a decimal, so let's leave the 2 in the radical. One way to write the answer for how long the hypotenuse is 5 times the square root of 2. Now please notice that 5 is the original length of the side of the square. And so this suggests a quick way to find the hypotenuse for this kind of a triangle. We can take the leg of the triangle and multiply by the square root of 2. Does that work all the time? Let's try one more example. Let's say that we have a 45, 45, 90 degree triangle, and that the legs of that triangle are, let's say 11. How long is the hypotenuse? Is it 11 times the square root of 2? Well, let's do the work the long way. 11 squared plus 11 squared equals C squared. This is 121 plus 121, which makes 242. Now we can do the square root of 242. We can factor 242 as 121 times 2. The square root of 121 is 11, and the square root of 2, let's leave as a radical. Our conjecture from before seems to be confirmed in the second example. We can find the hypotenuse by simply taking the length of the leg and multiplying by the square root of 2. And that's what this lesson is about. A special relationship in this kind of triangle that will make problem solving fast. I had you skip to question 4 so that we can answer part B. If we use the letter L to be the length of the leg of a 45, 45, 90 degree triangle, then we can find the hypotenuse H by taking the leg times the square root of 2. And here is our formula for 45, 45, 90 degree triangles. It gives a relationship between the length of the hypotenuse and the length of the legs. This formula could be rearranged so that the letter L is alone. So we could find the length of the leg by taking the hypotenuse and dividing by the square root of 2. I'm going to pause the video for you to write both of these formulas down here in the notes. In these formulas, the letter H is the hypotenuse of a right triangle. The letter L is the leg of the triangle. These formulas only work for this kind of right triangle. Let's go to the check your understanding questions and use those formulas to solve some problems, starting with number 5. Here we have a 45, 45, 90-degree triangle. We're given the hypotenuse, that's the H, and the letter X is on one of the legs, that's the letter L in those formulas we just wrote. We want to find L, so let's use our second formula. L equals H divided by the square root of 2. Substitute 17 for H and divide by the square root of 2. There's the answer. Now you might remember from algebra that we don't like to leave final answers with a square root symbol in the denominator. We're going to do what's called rationalizing this expression. Whatever that denominator is, you times by it in the top and the bottom. This creates 17 times the square root of 2 in the top, and down in the bottom, 2. Because the square root of 2 times the square root of 2 makes the square root of 4, which is the same thing as 2. Now our answer has a rational number in the denominator, not an irrational number. Let's go to number 6. Here we have a 45, 45, 90-degree triangle, and this time we know the leg, and we don't know the hypotenuse. So which formula should we use? We want to use H equals L times the square root of 2, and substitute 4 square root of 5 in for L. Now do the math. The square root of 5 times the square root of 2 is the square root of 10. So our answer is 4 square root of 10. Now I'm going to pause the video for you to work on number 7 by yourself. Decide which formula you need to use and then do the arithmetic. The variable x is on one of the legs of the triangle, so we want the formula that has the leg alone. L equals H divided by the square root of 2. Make the substitutions and then do the arithmetic. The answer is 5 square root of 6. Let's skip ahead to number 9. The perimeter of a square picture frame is 40 centimeters. Find the length of the diagonal. Always helps in geometry to draw pictures when you describe something in a sentence or a paragraph. So we have a square picture frame. If the perimeter is 40 centimeters, then each side must be 10 centimeters. We're asked for how long the diagonal is, so let's draw a diagonal and put a variable on there, like x or perhaps c, whichever variable you like. Do you recognize the special case triangle from this lesson? This is a 45, 45, 90-degree triangle. So a fast way to get the hypotenuse is to take the leg times the square root of 2. We could do the Pythagorean theorem, but this is a much faster way to get the answer. So in this lesson, we studied the 45-degree, 45-degree, 90-degree triangle, which is one kind of right triangle, and discovered a fast way to find the hypotenuse when we know the leg. It's faster than doing the Pythagorean theorem. We're also able to use that formula in reverse and find the leg when we know the hypotenuse.